So the initial value is 2. Our assumption that it is true for n equals to k. So substituting that into here, so far in our questions with inequality, we've always been given the initial value. So we've always been told that n must be greater or equal to a certain number. Now we're going to work with a question where it doesn't tell us this. So in question 3, we want to prove that n squared plus n is less than n cubed minus 1 by mathematical induction. And you notice a big gap here. It hasn't told you what n must be greater or equal to. And that means for us that we have to test out numbers and find out when the left-hand side is less than the right-hand side. So we always start off with n equals to 0. So left-hand side just equals to 0, whereas the right-hand side is negative 1. Now 0 is greater than negative 1, so left-hand side is greater than. So no, that doesn't satisfy that. Okay, moving on to n equals to 1. We have 1 squared plus 1 equals to 2. The right-hand side is 1 cubed minus 1, that equals to 0. And once again, the left-hand side is greater than the right-hand side, so it doesn't work for that. And so we just keep going on to the next number. So 2 squared plus 2 equals to 6. 2 cubed minus 1 equals to 7. So yes, finally, we see that this is when the left-hand side becomes less than the right-hand side. So we know we're working with n is greater or equal to 2. So the initial value is 2, which means now step 1, we go, show it is true for n equals to 2. So this here is the extra step that we have to take if we're not told what n has to be greater or equal to. Okay, so this is an extra step. Let's start with step 1 now. So show it's true for n equals to 2. Using this, which we've already done, kind of, left-hand side is 6, right-hand side equals to 7, left-hand side is less than right-hand side, therefore the statement is true for n equals to 2. For step 2, our assumption that it is true for n equals to k. So we assume that is that k squared plus k is less than k cubed minus 1. We've made the assumption and we move on to step 3, where we show it is true for n equals to k plus 1. So substituting that into here, that is k plus 1 squared, yeah, plus that becomes k plus 1. This becomes k plus 1 cubed minus 1. So this is the equation we're trying to prove, inequality. So I want you to keep that in mind. We want to prove that this side is less than the other side. All right, let's start off with the left-hand side. So we have k plus 1 squared plus k plus 1. So what we can do here is expand. They'll give us k squared plus 2k plus 1 plus k plus 1, which equals to k squared plus 3k plus 2. I want us to think back to what the assumption was. And the assumption was assuming k squared plus k. Even though we worked it out k squared plus 3k plus 2, we need to separate it into k squared plus k and then 2k plus 2 because I want to use this assumption here. So now I've separated it. Remember how we use this assumption is with a basic assumption in step 2, we know that k squared plus k is less than k cubed minus 1. If I add 2k plus 2 to this side, I must also add 2k plus 2 to this side as well. So always balance in 2. So therefore I can say this is going to be less than that. Okay, so I've balanced it. I'm going to use this whole thing in our assumption over here, which is that this must be less than that, considering we know that this is less than that. Yeah, makes sense? Good. Now what I'm going to be working with is this over here. Yeah? So we just have k cubed plus 2k minus 1 plus 2, which just gives me plus 1. So now I have k cubed plus 2k plus 1. Now I want to go back to my equation here and remind myself what I'm trying to do. I want to somehow make this look like that. That's what I'm trying to do, which means I want to know what this is. What's k plus 1 cubed? Now k plus 1 cubed is going to be k squared plus 2k plus 1 multiplied by k plus 1 when we expand it. So when we expand that, we're going to get k cubed plus k squared plus 2k squared plus k. We've got k cubed plus k squared, 2k squared plus 2k plus k plus 1. And that gives me k cubed plus 3k squared plus 3k plus 1. Now, why I've gone to all this effort to work this out is because I need a portion of this for my next step. And what I want to do is make a greater or less than this over here. So what I'm using is this portion. Yeah? I've moved this over here. So I've actually worked kind of backwards a little. I've gone back to the original thing and worked that out first. This was that. And now you can see, why can I say this is less than that? Well, that's because k cubed is the same as k cubed. Now, 2k is definitely less than 3k squared, isn't it? Because 2 is less than 3 and k is less than 3, is less than k squared. And we can also say that 1 must also be less than 3k because we know also that k must start from 2. So we can say that this must be less than that must be less than that. So therefore, this whole side must be less than that side, correct? This, I'm just going to add 1 minus 1. So what we have over here is we're trying to make this into that, right? But this just balances itself out. Plus 1 minus 1 equals 0. So we're not actually changing anything. But I want to add 1. So now I can factorize it into k plus 1 cubed. And that leaves us with minus 1 on the outside. And you can see that looks exactly like the right-hand side that we have here. Can you see that? That equals exactly the same as that. So therefore, we can say that the left-hand side is less than the right-hand side. So let's have a look here. Equals to less than. Equals to less than. So we have 2 examples where it's less than. So we can definitely say that left-hand side must be less than the right-hand side. Therefore, it is true for n equals to k plus 1. So therefore, for n squared plus n less than n cubed minus 1, it is true for n is greater or equal to 2. So the new things that we learnt in this question was to find out the initial value, we just test, starting from n equals to 0 until it does satisfy the equation. Just another thing is sometimes you need to go back to what we have up here, into the original question in step 3, and work from the right-hand side as well as the left-hand side, and use that information together to work the final answer out.